Okay, take two. Good afternoon again, everybody. So welcome back after the reading break. I hope you guys had a good one. Okay, and I hope you were not badly affected by the typhoon. Parang sila Ivy at saka si Ben Paul nakausap ko na about that. How about the others? Badly affected ba or okay lang? Naka-survive naman. Okay naman si Bemsor. Yeah, so I guess here we are in a very crucial time and medyo mahirap itong part na to kasi we build up academic momentum before we go to the reading break. Parang hirap mag-adjust after the semestral break, and then come the reading break where we have to relax, and then napahaba pa ng kaunti yung ating bakasyon and because of the typhoon. So ngayon, balik na naman tayo. Balik pagpapanggap na nasa academic shape na, but I hope you're getting ready for the home stretch, because medyo na-shock din ako kasi I was thinking about what to do today because I remember I promised you another problem set, which is basically a hands-on exercise on matrices and how it is used to solve applied problems. Kasi yung una yung problem set is just an exposition of two methods that we didn't have time to talk about. Naisip ko sana ay i-discuss ko ngayon yung MATLAB code that I was supposed to share with you para masagutan nyo yung problem set. The second problem set that I'm gonna give you. Kaya lang, tinignan ko yung schedule, yung timeline na sinend sa akin originally ni Sir Jomar. Last meeting ko na pala for Unit 2C on Friday. So we only have 2 meetings to finish Section 2C instead of the 4 meetings or 5 meetings that we should have had na naapektuhan nung suspension ng classes last week. So kanina medyo nagpanic na ako and I have to look for an introductory course or introductory materials for doing data analysis or using network analysis tools actually from graph theory. So here's what I'm going to do. So ang gagawin ko ay in the next couple of days, I'll record a sort of a tutorial or a walkthrough for the problem set that you will do. Merong isang problem, probably it's a discrete version of the heat equation. And papakita natin kung paano ginagamit yung solution ng linear systems in order to retrieve some information about the temperature flow in a rod. So makita nyo doon paano gagamitin yung either you can use LU factorization, QR decomposition, because that's a perfect example wherein we don't have access to the right-hand side data right away. So kailangan nyo munang mag-iterate. Meron kang initial data or initial temperature reading. Tapos, yun yung gagamitin mong right-hand side yung sa isang linear system. Tapos, to retrieve the initial condition that gave us the current temperature, you have to work backward. So, yung temperature reading ngayon, siya yung gagawin mong right-hand side dun sa isang matrix equation, say AX equals B1, okay? Tapos, there you will get the matrix X, the solution vector X. Yung makukuha mo solution vector X, siya yung magiging right-hand side dun sa susunod na iteration para makabalik ka one step further back in time. So you're gonna have AY equals X and then you solve for Y. That Y value will be the data that you will need to compute the previous time value hanggang makarating tayo dun sa initial condition. So basically, it's a backward iteration, an inverse problem involving the heat equation. But it's highly unstable. Meaning, pagka nagkaroon ka lang ng measurement error ng kaunti, napakalaki ng pagbabago dun sa solution. That's why you will need to use the L-curve method para ma-compute yung, or para ma-stabilize yung solution. So that will be probably a brief problem set. I'll give you the matrices. I'll give you the necessary mathematical formulation. If you haven't taken partial differential equations, it's fine. All you need to know is that we have a discrete version already. Meron ng matrix, alam niyo yung matrix A, tapos meron kang unknown vector X, equal siya sa measurement data B, but you know B is obtained by doing physical measurement, so that will be tainted by measurement error. So ang sinusolve nyo talaga b plus epsilon. And remember, we have discussed this. If you're solving ax equals b plus epsilon, we need to be careful about the effect of the tiny epsilon na measurement error dun sa right-hand side, because that can cause our solution to be far off from the intended solution. So yun yung gagawin nyo sa problem set. If you're not too inclined sa pagpo-program, don't worry, I'll record a tutorial or a guide or a walkthrough dun sa code na i-share ko sa inyo. But if you're good at programming and you want to do the programming on your own, you can also do so. I'll have the mathematical framework written down so you can write it into a program, run it, and using your programming language of choice, and then you can play with it, right? You can have fun with it. Pero kung hindi, pwede nyo gamitin yung MATLAB code na i-share ko. All right? So okay lang ba yun? So I hope you are also making progress with the first problem set para mabawasan na yung kailangan yung tapusin. I already received some submissions. I'll take a look at them probably within the week and give you my initial feedback. Wag kayong wag niyong masyadong pagbuhusan ng panahon masyado yon. So I think I said 2 to 3 pages. If you only had 1 page plus some change, that's fine. Consider na yun na 2 page. And about 1.03 pages or round up nyo na 2 pages na yun. So that should be fine. All right. Okay. So I think that's for our basic housekeeping. Let me know if you have some concerns. Pero ngayon medyo nagpapanik na ako. Kailangan pala nating medyo bilisan. All right. But anyway, let me share my screen to begin the discussion for today. Okay. Okay, so all right. So dahil sa pagpapanik ko kanina, looking for some materials, I didn't have time to prepare new ones. So I just adapted the one prepared by Dr. Rabahante, which is based on the lecture on network science by Albert Laszlo Barabasi. It's quite a lengthy slide presentation. Tapos mag-insert ako ng some MATLAB codes in the middle. So probably won't finish everything today. So probably we'll come back to it. And then there are 2 other subtopics under this unit. Probably I'll just assign them as a reading assignment to you. Though nung nireview ko naman yung course outline, parang ano to fundamental methods in data science or data analysis. So hindi naman sinabi na kailangan tapusin natin lahat ng methods. So I just want you to experience specific methods. And when a particular method is required in your thesis, I think or I trust that you can study them on your own. Pero ito yung parang introductory para makita nyo ano yung mga mathematical tools that are available at our disposal in order to solve these big data problems. And one of them would be the class of methods coming from graph theory. Okay. So this is very important because most of the information or data that we are trying to analyze, especially in the age of big data, are coming from networks. So meaning we are looking for the interconnection or the relation between several things. And mathematically, maganda silang pag-aralan using some graph theoretic properties. So this is a little bit of a deja vu because during my undergrad, I work on graph theory, though it's more algebraic. So pero etong titingnan natin ay medyo mas computational or mas applied na side ng graph theory. But of course, we always start with the definition of what a graph is. So basically, a graph is a discrete combinatorial object. So it is actually depende sa book na babasahin nyo. I usually define this to be a triple, pero I guess in these slides, it is defined to be a pair. So you have a set of vertices and a set of edges. So meron kang vertices which can be represented by dots, circles, points, etc. So pwedeng tingnan mo to as concepts, ideas, persons na gusto mong tingnan yung interconnectedness. So mga vertices, so graphically, pakita ko siya dito as circles. And then we have set of edges that can denote the relationship between these objects. So meron kang vertex, gumagana ba ang pen ko rito? Okay, there you go. Meron kang vertex A, which is connected to vertex C through the edge we call AC. And then vertex A connected to vertex B via the edge AB. So yung vertices, mga nodes, mga points, and then edges are line segments joining this vertices. And usually you can interpret it as A and B being connected by an edge if there is a defining characteristic or relationship between the two. So you can define, say, person A at saka si person C. They will be connected by an edge, even only if, say, they are friends in Facebook. And the non-existence of an edge between the two, say vertex C is not joined to vertex D via a node, that means that C and D are not friends in Facebook. So, kaya magandang visual representation ng relation, or parang ano nga siya, for simple graphs, it's a bilateral or it's a binary relationship between the two objects or between two concepts, right? So yeah, so these are the two basic building blocks for graphs. You have a set of vertices and set of edges. And that pair will constitute, or the set of all edges and the set of all vertices is what we call the graph G. Medyo abstract yung definition, ano? And yeah, and that's what we have here. So ang graph G ay yung pair ng set of vertices and edges. So in this particular example, our graph G has 4 vertices, namely A, B, C, and D, and it has 4 edges. The edge connecting A to B, so this guy, and then the edge connecting B to D, this guy, the edge connecting A to D, and the edge connecting A to C. In this particular case, pwede nating sabihin na yung isang graph ay synonymous sa isang network. Because again, you build networks by defining a characteristic between two members of the network, all right? So kaya maganda, kaya ito yung ginagamit nating pang-analyze ng networks. Now, every vertex is synonymous to node. Though sinabi rito ni Sir ay synonymous, but for me, vertices and nodes are just equivalent to each other. They are the same thing insofar as graph theory is concerned. But I guess here, gusto ni Sir ay magkaroon ng distinction between the mathematical object that is a graph consisting of abstract objects or abstract sets of vertices and edges. Meanwhile, the real life application would be networks, which are composed of nodes and links. Pero they are isomorphic to each other. So probably we can interchange the use of these terms, okay? Now, well, yeah, so if you have a set of computers connected via local area network or related via the internet, so you can have a network of computers, right? But once you take away the hardware component of it, you replace the computers by points, and then the edges, the connection between these computers by line segments, then you'll get a graph. But again, for me, they are just the same thing, okay? So, okay, so some semantics here. I'm gonna skip some of the slides. Well, any presentation about graph theory won't be complete if we don't talk about the bridges of Königsberg, which is a classical problem, which is posed in the 1700s, which was considered to be the origin of the subject we call graph theory. So sa Kaliningrad, Russia, in 1735, merong ganitong problem. So meron kang itong Königsberg, which is a city consisting of 4 components to which the Pregel River is passing through. And then there are 7 bridges connecting the 4 components of the city. So component 1 of the city, component 2, 3, and 4. And then you see here the Pregel River, the blue one. And then you have the 7 bridges represented by the red line segments here. And then the problem, for whatever reason, sabi ng mga taga Königsberg, sige nga, kaya mo bang dumaan doon, kaya mo bang madaanan lahat ng bridges by with the condition that you only pass through a bridge only once. So hindi ka pwedeng bumalik, and to remove all ambiguities, pagka tumapa ka sa isang bridge, dapat lulusot ka na dun sa kabilang dulo. So once you enter the bridge, you should exit the bridge on the other side of the city. So yun yung condition dito. Is it possible that you can walk across all the 7 bridges and never cross the same bridge twice? Okay. And a lot of people try to answer this problem, and it was Euler who proposed a rigorous proof in 1736, saying na hindi posible na magawa mo yung walk, na hindi ka daraan sa isang bridge more than once. And actually, the argument is quite simple. Binilang niya lang yung degrees, sabihin niya lang na there is a bridge having an odd number or sobra yung number of bridges, number of nodes with an even number of edges attached to it. So yun yung ginamit niyang proof. But I don't want to go into the details of the proof, pero ito yung naging simula, or this is the birthplace of graph theory. So basically, this is the notion of, or this is what mathematicians do best. Meron kang isang practical problem. And then what we do as mathematicians, we simplify the problem down to the point that we are stripping the problem down to the barest essentials. So meron kang map. Tapos medyo komplikado kung i-analyze siya in terms of cities. I'll take away all of the unimportant physical components to it. So mula dito sa mapa na to, naibaba or na-simplify ni Euler yung kailangan niyang i-analyze. Each of the 4 land masses in Kaliningrad is represented by nodes or vertices, and then the bridges are represented by the nodes. And then by just counting the number of edges coming out of a land mass, na-prove ni Euler na hindi posible na makapag-devise ka ng isang path na makakadaan ka sa lahat ng 7 bridges with the restriction that you only pass through all of the bridges only once. Okay. Now, that simple proof that Euler provided actually spurred the study of graph theory. Ang daming properties ng isang network o ng isang structure that is modeled by graphs that can be deduced by some parameters of the graph itself. And basically, that's what we want to look at today. What are the parameters or useful parameters ng isang graph that can give us some insights onto the relationship of different nodes or different real life concepts or real life persons? So kasi ngayon, ang daming data, halimbawa sa Facebook na lang. I'll go back to the Facebook example over and over again throughout the talk. Pagka inassign mo bawat isang friend mo to be a node, and then 2 nodes or there's an edge between 2 nodes, if and only if there are friends in Facebook, then you can get some nice insights doon sa relationship ng mga tao that you represented by nodes. Later na lang. Mamaya ko na lang bibigay yung specific example. But let's see. Some of the basic parameters na kakailangan natin all throughout the talk. Or by the way, before I go there, sayang naman yung trivia na nabasa ko kanina when I was reviewing Königsberg. So I was a bit curious of gaano na-preserve yung Königsberg bridges. And it seems that meron pang dalawa dun sa original bridges in the 1700s ay nakatayo pa rin ngayon. Alright? Though dalawa ay na-destroy sa World War II, yung dalawa pinalitan na ng highways, yung isa ay ni-rebuild nila noong 1935, pero may dalawa pa dun sa original bridges na natitira today. Alright? So just a hint of trivia. Okay, so some basic parameters that we might need in our analysis of graphs. Una, yung number of vertices. So this is just the cardinality of the vertex set that you have, and we call that the order of the graph. Okay, so ang order ng graph, ilan yung edges. Now, if you count the number of edges let's denote it by capital L. Ito naman yung size ng graph. So our graph G here is of order 4 because it has 4 vertices, and it is also of size 4 kasi 4 yung edges niya. Oh, by the way, this is an example of a simple graph. So simple graph siya kasi an edge from vertex A to vertex C is considered to be the same as an edge from vertex C to vertex A. So yung edge AC, it's one and the same with the edge CA. So we don't give any distinction as to saan nagsimula yung edge at saan siya natapos. If you're working with graphs like that, we call it a simple graph. All right? Kaya isa lang yung bilang dito sa mga edges na nandito. Okay, so we have this example. And then there's another type of graphs, and this is called a digraph or a directed graph, wherein yung starting point ng isang edge matters. So basically here, for instance, we have the edge AC here. In a digraph, we consider it to be a separate edge from the edge containing or the edge starting from C to A. And that would be counted twice, right? So this is also useful if you have a possibly biconditional relationship. For instance, this network, say, describes sending emails, right? Wherein you have an edge from vertex I to vertex J if node I sent an email to vertex J. So, posible na si I ay magpadala ng email kay J, pero si J hindi magpadala ng email kay I. So if you will be counting outgoing emails as the relationship here, and you define vertex A to be adjacent, or ito pala, define ko yung term na adjacent para mas madali. If there is an edge from vertex A to vertex B, then we say that A is adjacent to vertex B. Okay? So if you are in a digraph, it's important. Kanino nagsimula at kanino natapos. So that's why here, if again, this is an email sending network wherein there is a directed edge from vertex A to vertex B if and only if node A sent an email to node B, right? So magkaiba yung vertex AB kaysa kay vertex BA. Kasi ang ibig sabihin ng vertex na to, ng edge na to, si vertex A ay nagpadala ng email kay vertex B. Pero si vertex B, hindi siya nagpadala ng email kay vertex A. Alright? So yun yung, ito yung kapag ka hindi reflexive yung relationship between the nodes in the network. Alright? So if you have to draw a distinction between the endpoints of the edges. In particular, alright, so in this example, examples ng digraphs, one-way transportation network, I guess here, Sir Jomar meant sa one-way transportation network kapag ka meron kang roads na one-way lamang. Kasi from point A to point B, makakapag-travel ka from point A to point B. So A, there is an edge from vertex A to vertex B. Pero kung one-way yung road, then hindi necessary na merong path from vertex B to vertex A. Right? So that's just a quick example. And this is the example I mentioned kanina, sending of email network and assembly line. So ito ay kung gumagamit tayo ng digraphs kapag ka importante yung ordering ng mga edges o yung relationship between the vertices. Okay? So if that is the case, then in this digraph G or in this digraph H, the order is still 4 because we have 4 edges. We have 4 vertices. But the size now is how many? The size now is 5 because we have 5 edges. This one, another one, 3, 4, and 5 edges. Because again, we count edge AC and edge CA separately. Okay? So pagpasensya nyo na, maraming definition tayo ngayon. Ano? So, okay. Now, parameters pa rin. So the degree of a vertex. So the degree is a measure of how connected a vertex is to another vertex. So ang vertex denoted by K sub I of the vertex I is how many edges is connected to the vertex I. Bibilangin lang natin ilan yung related via the defined relation in the network kay node I. So for instance, in this example, all right, recitation sana tayo, kaya lang nasulat na pala yung sagot, ano? If you look at the degree K sub A of vertex A, so punta ka kay vertex A, bilangin mo lang ilan yung adjacent kay vertex A. So we have vertex C because there's an edge AC. Then D is also adjacent to A because there's an edge between A and D. And A is also adjacent to vertex B. So perfect. KA has degree 3 because the maximum degree of a vertex in a simple graph is equal to n minus 1, right? Or capital N minus 1, the order minus 1, because we don't allow loops. Bawal yung edge from a node to itself. Okay. Another example, if you consider the vertex C, all right, and you compute for its degree. So ano yung degree ni vertex C? Bilangin nyo lang, ilan yung kapitbahay, ilan yung connected na vertices kay vertex C. Well, we have vertex A for sure because there's an edge AC, but there's no other node connected to C other than A. Because C and D are not adjacent to each other, ganun din, hindi rin adjacent si C kay B. So the degree of the vertex C is just equal to 1. Okay? So bilangin lang ilan yung kanyang kapitbahay. Now, what is this? Okay. KI3, vertex 1, KB. All right. So if we here we have this particular remark. Sabi niya yung size. Remember, the size is denoted by capital L for our lecture. So ang size daw ng isang graph ay yung kalahati ng summation ng degrees ng lahat ng edges. Why do you think that is the case? If you want to verify, well, here are the vertices. Here are the degrees of our vertices. You take the sum, we get 5, we get 8 divided by 2, so 4. Ang size daw ay 4, which we already knew to be true. Why do you think we have this formula? Bakit sa isang directed graph, sa isang undirected graph, sa isang simple graph, ang size niya ay kalahati ng sum ng degrees? Anyone?
Sir, sa degrees kasi twice nakakount yung mga edges.
Okay, great. Thank you, Ben Paul. Kasi nga twice nabibilang, ano? Kasi halimbawa, itong edge AC, nabilang na siya dun sa degree ni A. Tapos, nabilang din siya dun sa degree ni C. Kaya kailangan kunin natin yung kalahati ng summation ng mga vertices, right? Because there's only one way in a simple graph for vertex A to be adjacent to vertex C. And that is if there's an edge between the two of them. So, magkaiba yung bilang mo or nabilang mo twice, halimbawa si edge AC, nabilang mo siya dun sa degree ni A, nabilang mo rin siya dun sa degree ni C. So that's why kailangan mong kalahatiin yung summation ng mga degrees. Okay, great. Now, in a digraph, mamaya pa pala yung digraph, but so yung degree ay measure or isang parameter attached to each of the vertices. Now, if you want to characterize a parameter for the graph, usually ginagamit natin ay yung average degree, which is, as the name implies, this is just the average of the degrees in our graph. So denoted by bracket K. So basically, in these slides, kapag enclosed in angular brackets, ibig sabihin average lang siya. So this is bracket K, this is the average degree, and as the name implies, kunin lang natin yung average ng mga degrees ng isang graph. Okay? So that would be 1 over capital N, 1 over the order, times the sum of the degrees. Okay? Alam na natin yung sum of the degrees ay equal kay what? This is equal to 2L, right? Because as we have remarked earlier, L is equal to the summation times 1/2. So the summation will be 2L divided by N. Okay? So what can we say if our graph has a large average degree? Ano yung pwede nating makuhang implication? So, halimbawa, meron ako yung graph, pinakompute ko sa MATLAB o kay Mathematica yung average degree, and I find out that I have a huge average degree. So what could be an implication of that? You can give a particular scenario. Sige nga. Yeah, feel free to unmute yourselves. Hindi kasi katulad ng team na nakikita ko kayo on the side. Or is there an option for that? Tingnan ko. Hindi ko alam. Hindi ako marunong sa Zoom. Pero,
May view, sir, sa pinakataas yata.
sa view. Kasi hindi ko kayo nakikita. Yun yung ayoko.
Tapos, side-by-side gallery. Kaso, naka-off lahat ng cams.
Ayoko na. Ayoko na siyang hanapin. Dito na lang sa tablet. Tingnan ko kung kaya pa. Anyway, so sige. Anong implication pag malaki yung degree? Sige nga. Para hindi lang ako yung nahihirapan pagka-klase natin. What can you say if your graph has a huge average degree? Or what could be an insight that you can draw from that? Or baka naman wala palang insight na makukuha from that. So wag na lang natin computein yung average degree. So what say you? What do you think? Walang gustong sumagot. Bala kayo, ipapa-problem set ko yan pag walang sumasagot. It's an open-ended question, guys. So, wala namang minus kapag hindi tayo parehas ng iniisip, ano?
Sir?
Yes, go ahead.
Michelle po.
Go, Michelle.
Siguro po ay mataas po yung connectivity ng mga edges, ay ng mga vertices pala.
Okay, that's great. Though ayoko sana gamitin yung term na connectivity kasi technical term siya sa graph theory, but I know what you mean. Ano? Kapag mataas yung average degree, so you can think of it as there's a strong relationship between the nodes in the nodes in the network. So if you have a Facebook friend network, pag mataas yung average degree, ibig sabihin maraming tao dun sa network ang friends ng bawat isa. All right? Or or something like that. Ano? So there's a strong relationship between the nodes in our network. So yeah, thank you, Michelle. Okay, so okay. So in a digraph, so punta tayo sa digraph. Dito medyo kakaiba, pero konti lang naman yung adjustment. Meron tayong dalawang klase ng degree na tinatawag. We have the incoming degree, which is basically we denote it by K upper N sub I. So ito yung incoming degree ng vertex I. Ito naman yung number of edges na papasok kay vertex I. And similarly, the outgoing degree is the number of edges that points outward from vertex I. So let's see. What do you think is K sub I of, K sub A incoming? What's the incoming degree of vertex A? Michelle says 2. Tama ba? Bilangin lang natin ilan yung papasok kay vertex A. So you have an edge coming from C going to A, so that's 1. And then we have another one coming from vertex D papunta kay A. So I think that's right. Thank you, Mitch. How about the outgoing degree? K sub A out. K sub A out ay 2 rin, no? Because I have the edge AC and then I have the edge AB. So that's the outgoing degree of the vertex A. Now, what do you think would be the formula? Formula kagad din, no? So how does the sum of the degrees, the incoming and the outgoing degrees related to the size of a digraph? Kaya sabi natin ang size ng isang simple graph o simply graph. Pag sinabi natin graph, ito yung undirected graph. So sabi natin ang size ng isang graph ay 1/2 ng summation ng mga degree. What do you think about the size of a digraph? How is it related to the incoming and the outgoing degrees of each of the vertices? Sige, you can draw a hypothesis by looking at the values here. Hopefully, you agree with this numbers here, all right? So, bilangin natin yung nandito. So, we know that the order, capital N, is 4, while the size is what? 1, 2, 3, 4, 5. Because we're counting each of the edges once, ano? So, based on this values, what do you think, or what's our hypothesis for the size of a digraph?
Sir, tungkol sa size ng digraph,
Yep. So si L.
well,
Ano formula ko
sa
kay L?
degree ng in, tsaka equal din sa sum, sa total na degree ng out din.
All right. So it is equal to either the sum of the incoming degrees or the sum of the outgoing degrees, right? For all i's. I think that's right. Okay. Okay. So yeah, this and similar to the properties of a graph, pwede nating tingnan yung average degree ng isang digraph. And we define the average degree of the digraph to be either the average of the incoming degrees or the average of the outgoing degrees, which is well defined kasi nakita na natin kanina na ito at saka ito, both of them are equal to the size of this is equal to the size of our digraph. Ano? So, well-defined yung equality na yan. So, we can compute the average degree of a digraph by either looking at the average incoming degree or the average outgoing degree. But as Ben Paul said kanina, ang incoming degree ay equals, or ang sum ng incoming degrees ay equals sa size. So basically, the average degree of the digraph is just equal to L over N, the size over the order. Okay? So, yeah. If I will just use now probably you start to realize that just looking at the average degree of a digraph, medyo hindi ganun kalaki yung nakukuha nating information or insight mula sa parameters na to. Kasi yeah, you can say that on the average, probably if L over N is much greater, is a huge number or is a large number, that means mataas yung average degree. Ibig sabihin, strong yung characteristic. But it's more of a global measurement. So it's a bird's eye view of what's ever happening on the network is. Pero minsan, hindi natin gusto na ganun lang kaliit yung tinitingnang description doon sa ating network. But this is easy to compute, right? So if you have your digraph, alam mo yung vertex set, alam mo yung edge set, madaling kunin yung average degree. It's just the size over the order. Or in the case of a graph, it's just twice the size over the order. Makikita mo na kagad, magkakaroon ka ng idea gaano ka close yung relationship sa kanilang dalawa. But again, as any measure of central tendency is limited, kailangan mag-supply tayo ng iba pang parameters para ma-augment yung insights na nakukuha natin mula sa pagko-compute lamang ng degree ng isang graph. Okay? But nevertheless, it will give us a good idea, a starting point for discussions for analyzing big data or big networks. Okay, now, aside from looking at the average, if you want to know, kung gusto mong mag-dig deeper into the connectivity, kaya lang technical term nga pala yung connectivity, dun sa strength of the relationship or the level of the relationship between the nodes, probably you want to look at the degree distribution. The degree distribution of a graph denoted by pk is basically the probability that a randomly selected vertex in the graph has degree k. So ano yung probability na pag pumili ako ng isang vertex sa graph, ganon yung degree niya. Alright, so P or parenthesis PK, ito yung ayoko sa mga AS notations. So magkaiba yung ibig sabihin pag naka-parentheses at naka-brackets yung quantities. So if you have parenthesis PK, this is the degree distribution. So parenthesis P sub K is the probability na pag pumili ako ng isang vertex, ang degree niya ay K. So essentially, to compute P sub K, buti na lang tinanggal niya na yung parentheses, ano? Pero si P sub K ay, this is the probability that a randomly chosen vertex has degree K. So basically, pag kinompute mo yung probability, simple combinatorial exercise, it's just the number of vertices with degree K divided by the order. So titingnan mo lang anong proportion ng mga vertices ang may degree K. I-divide mo by the order, makukuha mo yung probability P sub K. And then you collect all of those probabilities for all K starting from 1 until the size. Ano nga ba yung maximum degree? This would be from 1 to n minus 1. Alright? So pag meron ka ng n minus 1 number, makukuha mo na yung degree distribution. Okay? For example, P sub 1, this is the probability that a randomly chosen vertex will have degree 1. So bilangin lang natin ilan sa mga vertices na to, o ilan sa mga vertices natin ang may degree 1. Si CI degree 1, si AI degree 3, si BI degree 1, 2, 3, tapos si hindi 3, 2 lang pala to. Tama, 1, 2, 3. Tapos si BI degree 2, tapos si DI degree 2 rin. Okay. So P sub 1, meron lang tayong isang vertex out of the 4 that has degree 1. So ang P sub 1 ay equal kay 1/4. So if you randomly select a vertex coming from our vertex set, there is a 25% chance that that vertex has degree 1. Tapos P sub 2, ano yung probability na pag pumili ako ng vertex, ang degree niya ay 2. So bilangin natin, ilan yung degree 2 vertices? We do have 2 degree 2 vertices, vertex B and vertex D. So meron tayong 2 out of the 4, so that's 2 over 4 or 50%. And so on. And then there is no chance that we get a vertex of degree 4. Kasi ang maximum degree lang sa isang simple graph ay order minus 1. Right? So this guy will be 0. And since P sub K is a probability distribution, the summation of the probabilities must be equal to 1. Okay? So yun yung basic property ng degree distribution. Okay? Right? And then moreover, the average degree of the graph is the expected value of this probability distribution. So basically, this is the sum of K, the degree, times P sub K. All right, so if you're more into probability, then you want to look at the average degree as the expected value of this distribution. Okay? Pero mas madali siyang compute na bilangin na lamang, kunin na lang yung average ng mga degrees. But that's fine. It's just a discrete probability distribution. So that's good. Okay. Now, can you give some reasons why degree distribution is important in real-world application of graph theory? Or medyo mahirap pa tong isipin, especially if this is the first time that you are hearing this terms, ano? Kasi kanina madaling isipin yung degree ng bawat vertex or yung average degree. Now, siguro later nyo pa makikita or ma-appreciate kung para saan yung pagtingin sa degree distribution. But I lifted some examples here. Okay. So halimbawa, we do have 2 examples of graphs here yung unang graph, yung degree distribution niya is plotted in this histogram, yung kulay black versus yung kulay gray. So dalawang magkaibang graphs sila, but these two graphs have the same kind of degree distribution. Ang degree distribution nila ay isang Poisson distribution. Okay. Ito yung formula ng P sub k. P sub k is equal to e to the negative c times c to the upper k over, not c to the upper k, c to the k all over k factorial, where c is a constant. So I think this is always assumed to be a positive number, right? So if your degree distribution can be written in the form e to the minus c times c to the k all over k factorial, then you have a Poisson distribution. Okay, and here we do have the histogram of the degree distribution of two graphs, na Poisson yung distribution. They just vary with the constant c. At makikita nyo rito medyo mahirap makita yung relationship, or parang mahirap pa rin makakuha ng insight mula dun sa degree distribution na yon. Pero madaling isipin o madaling basahin yung histogram. Halimbawa dun sa gray graph. So halimbawa 5. So ito yung histogram na 5. So that means there is around, say, ilan to? Siguro mga 27%. There's a 27% probability that a randomly chosen vertex will have degree 5. All right? Or halimbawa kung ito yung 4, pinakamadalas na degree ay 4, right? So there is around close to this is not 17, sorry. This is about 17%. So there is close to 20% of the vertices has degree 4. So madali mong makikita ano yung pinaka-frequent na degree ng isang vertex. Although pag sinabi mong Poisson distribution yung kanyang degree distribution, medyo mahirap pa rin humanap ng properties, So kaya kailangan, or hindi sufficient na measure lamang ng property ng isang network yung degree distribution. Because here we have dalawang Poisson distributed degrees, pero magkaiba yung property. All right? So it's just characterized by having, say, a peak somewhere. Okay? Tapos, medyo magkaiba yung behavior nila. Ito medyo malapit nga sa bell curve, pero ito medyo pagano naman yung itsura niya. Okay? So this is one. Actually, Poisson distribution, ang value nila ay more on the theoretical aspect, because this certain distribution doesn't come up in practical scenarios. Pero ito yung unang ginamit ng mga unang network analysts sa pag-describe ng topology coming from this particular distribution. But I don't want to go into that details kasi mas theoretical yung aspect ng Poisson distribution. Some more insightful kind of distributions. Ito naman on the left ay yung binomial distribution. Ang binomial distribution naman ay, hold on, I have my notes there. Ang P sub k naman ay equals hindi pala pwede sa second screen magsulat. So ito ay equals n minus 1 taken k times p to the k times 1 minus p raised to the n minus 1 minus k. Where p is the probability na connected ang dalawang graphs doon sa connected or adjacent yung dalawang vertices doon sa ating graph. So basically here in the binomial distribution, p is actually our parameter that will describe this distribution. Little p is a constant between 0 and 1 because again, it's the probability that two randomly vertices are adjacent. Tapos yung mga little n's ko dito, dapat capital N sila. Yan yung order ng ating graph. Okay. So here medyo binomial yung distribution. So here in this figure, we have the degree distribution of 10,000 nodes na ang average degree ay 10. So you see here that the peak happens at around k equals 10. So that means majority, actually hindi naman majority, a plurality of the vertices have degree 10, right? So that's about, say, 12% of our nodes has an average degree of 10. Okay. Now, we often see medyo bihira rin yung yung binomial distribution in applications. The more exciting ones are the exponentially distributed degrees or the exponential degree distribution. All right. For example, ito. So you have 10,000 nodes, and each of them has and this network has an average degree of 7. Okay. So makita nyo ang average niya ay 7. So medyo maliit. Nandun lamang yung, or actually mataas masyado yung distribution around the average degree. So you have around 90%, close to 100. Close to 90% of our nodes have degree close to 7. Tapos pababa na siya ng pababa as you go along in the degree axis. So paunti ng paunti yung high degree. So meaning, ano yung pwede nating tingnan dito? Or ano yung pwedeng, ano sa tingin nyo yung mga examples, mga practical scenarios wherein you have a network that is exponentially or merong power law distribution. Okay. So I say it's an exponential or power law distribution kapag kaganto yung itsura ng P sub k. Either, so ito yung exponential topology or yung exponential distribution, ang P sub k ay equal kay constancy, which is a parameter in the model, e to the negative alpha k. Okay. So kapag kaya yung probability for some constant c and alpha, ang tawag natin doon ay exponential yung distribution. Sorry sa screen ako ng laptop nagsusulat, hindi sa tablet. So, or pwede ko bang gawin sa tablet? Hold on. Baka kaya kong agawin yung... Okay, mukhang kaya ko siyang agawin. And then an alternative to the exponential distribution is the power law distribution. The power law distribution. And the power law distribution is this. This is P of k or P sub k. Ang P sub k ay equals constant c times k to the negative alpha. Okay. So c is your normalization constant. And alpha is your exponent or another constant. And alpha is normally a number between 2 and 3. Which is always positive, but most of the times between 2 and 3. So power law distributions often occur in nature. Halimbawa, you can think of this network to be a network of airports or hubs, transportation hubs, na majority nung mga airports mo ay connected to other airports by, say, by a route, meaning airport A is adjacent to airport B if there are flights coming from airport A papunta kay airport B. Okay? So, mataas yung majority or a huge number of the airports have degrees close to the average degree. Kasi nga, pwede mo silang tingnan as transportation hubs. Probably you can think of those outliers in the tail end of the distribution to be those airports na kakaunti yung flights na pumupunta sa kanila. Or ito yung mga kailangan mo ng multiple flights para makarating doon sa isang airport na yon. So yeah, this could be a model for transportation hubs. Example, ginagamit din siya sa metabolic networks within a cell. So halimbawa, yung E. coli metabolism ay may power law distribution na ang alpha ay 2.2. Citation indices din sa mga researches. I think in the physics, nung minodel nila yung citation sa physics reviews. So two papers are connected to each other if one cited the other. All right. So ang power law parameter nila, ang alpha nila ay around 2.3. I'm just not sure what the normalization constant is. Hindi ko siya nakita kanina. Pero yon, around 2.3. But they follow a power law distribution, meaning there's a good actually hindi good yung tamang term pero yung distribution ng degree, all right, ay medyo heavy towards the average distribution. Okay. Tapos meron ka lang outliers. So you have probably one U paper that is just cited in one paper, all right, or sinite niya lang yung isang paper kasi nga bago pa lang siya. Right. So here are some others. So kailangan ko pala itong i-clear. Here are some other power law distributions. So collaborations in math papers. Ito, example ng citations. Pati yung interaction between internet pages. Then power grid ng US. Though mas exponential yung degree distribution ng power grid sa US more than a power law. Tapos yung protein interactions, ayun din, power law din yung kanyang distribution. Okay. So, but these are nice things to look at, especially if you have a huge amount of data, pa-compute mo lang, export mo lang yung data into, say, MATLAB or Mathematica, and then you can ask it to compute it automatically. All right. I hope to show you an example in a few. So, kailangan ko lang tapusin yung preliminaries na medyo mahaba-haba pa yata. Okay. Probably should I skip this? Probably I can skip this, yung adjacency matrix, I don't know if we will be using it, but I'll share with you a copy of this slide. So if later you'll need to make use of the adjacency matrix, then you can just read it through. But in summary, the adjacency matrix is just it's just a nice way of arranging or representing the graph. Hindi kasi napaka-hassle na isulat mo yung edge set. Kasi para masulat yung edge set, kailangan mong isulat ano yung dalawang edges, ano yung dalawang vertices na kinoconnect ng isang edge. So but in a matrix form, you can write it as you have a matrix A, the entry on the ith row and the jth row is equal to 1 if there's an edge pointing from vertex J to vertex I. So you can come up with a matrix that looks like this. Okay. So ito yung adjacency matrix ng graph G natin. So look at the entry here. Wala pala akong color. Okay. So look at the entry here kay AB. Wala akong pen. Yeah. Kay AB. So ang entry sa row A, column B ay equal kay 1. So that means there is an edge pointing from B papunta kay A. Though hindi naman nagmamatter kung kanino ka nagsimula kasi undirected yung graph natin. All right? And there's an edge from A to B, so there it is. Kaya 1 yung entry dun sa matrix. But you see here that from the entry on row C and column B ay equal kay 0, ibig sabihin walang edge na nagpo-point from vertex B papunta kay vertex C. Right? So here is vertex B, walang edge connecting vertex B directly to vertex C. So that's why this entry is equal to 0. And you see how compact this representation for the graph is. Actually, ito yung madalas na ginagamit na pag-store ng isang graph in a computer, for instance. Kasi mas madaling i-handle in a memory ang isang two-dimensional array. And the nice thing about this is you can dig through graph theory literature on how to compute some graph parameters just looking at the adjacency matrix. For instance, I guess the size of the adjacency the size of a graph is just half the summation of all the entries in your adjacency matrix. Tama? Kasi pag kinuha natin yung sum ng laman ng matrix na to, siya ay equal kay 8, kalahati nun ay 4, which is the number of edges in our graph. Okay? And then if you want to find the degree of a vertex, you simply take the row or the column sum in an undirected graph, right? So pag kinuha ko yung column sum, 3, ibig sabihin 3 yung degree ni vertex A. Kasi tatlong edges yung nanggagaling kay vertex A. And so on. So there's a lot of parameters that you can discern from the adjacency matrix. Kaya I remember some time when I needed to find some graph parameters, as masyado ng malaki yung graph, kinuha ko yung kanyang adjacency matrix, then I stored it in a computer program, and then I asked the program to do some operations on the matrix, say kunin yung eigenvalue, kunin yung row sum, kunin yung determinant, and so on. I was able to extract some parameters for the graphs. So if you want, if you're interested into that way of finding graph properties coming from the adjacency matrix, probably I can point you out to some graph theory literature. Okay, but we won't discuss all of them in details. But if you wanna take a deeper dive into this topic, so pwede nyo balikan na lang itong slide na to, itong slide presentation na to. So there's also a version of the adjacency matrix for digraphs. Ito yung nagmamatter kung kanino nagsimula yung edge papunta kanino. I guess here in this notes, ang kanyang convention ay nagmumula dun sa column label papunta sa row label. For instance, how do we check that? AB. So ang AB. Meron akong AB. So pointing from A papunta kay B. So meron akong simula kay A papunta kay B. So I have entry 1 here. All right? So tama. Yung column nagsisimula sa column label papunta sa row label. But of course, you can interchange the roles and just be consistent with your notation. All right? So the convention in the slides, nagsisimula yung edge sa column label papunta sa row label. Okay, you see here there's an edge starting from A papunta kay B. There we go, from A to B. That's why 1 yung entry rito. But there is no edge starting from B to A. So kaya was 0 yung entry kay column B, row A. Kaya 0 ito. Okay? And if this is your convention, then the incoming degree of a vertex is the row sum, while the outgoing degree would be the column sum. All right? But I'll just brush through these slides. Okay. Then there are some examples here that you can look at. Sparse networks, I think I can skip this. Dense networks, basically, ito naman yung mga networks na ang laki nung size, right? So this is an example of a complete graph wherein an edge is connected, a vertex is adjacent to every other vertex. Okay? So ito na yung pinaka-dense na network. Ibig sabihin, itong node na to or itong vertex na to ay adjacent sa lahat ng natitirang mga vertices. Right? So if say the order of this is n, what do you think is the size of this matrix? Sige. So ito na yung pinaka-dense. So this will give us the upper bound for the size of a undirected graph of order capital N. So sige nga, anong size nito? Any idea? So I guess here it's n taken 2 or n minus 1 taken 2. I think it's n taken 2 yung size ng ating network because you take all the possible combinations of pairings or possible pairings of edges of vertices. So I guess meron yan dito. Okay. Yeah, it's n taken 2. Kasi kapag ka-complete yung graph, ibig sabihin, kumuha ka ng kahit anong pair ng dalawang vertices and they will be adjacent to each other. So merong edge mula sa isang vertex papunta sa kahit ano pang vertex. So basically, it's just taking all the possible pairings of vertices. Tapos pag nakuha mo na lahat ng posibleng pairing ng mga vertices and there are n taken 2 of them, magdodrawing ka ng isang edge between them. Right? That's why each pair will correspond to an edge. So ang maximum, ang upper bound ng size ng isang graph of order capital N ay capital N taken 2. And of course, the minimum is 0 because you can have an empty graph. Ang empty graph ay isang graph na empty yung edge set. So for instance, saan ako pwede mag-drawing? Dito na lang. Ito, pag meron akong 4 na points na walang edges joining any of the vertices, then it is what we call the empty graph. Okay? Ang definition ng empty graph ay empty yung kanyang edge set. So these are the two extremes. The empty graph is basically the most sparse network. Pag sparse, ibig sabihin ko konti yung edges. So wala nang mas kakaunti ang edges kaysa sa network na 0 yung edges. Meanwhile, on the other extreme, we have complete graphs wherein any two nodes are related to each other via the defined relation and the maximum size is n taken 2. All right. Okay, now, what do we call weighted graphs? Pwede siyang digraph, pwede siyang undirected graph. Ito naman ay meron tayong value o cost na ina-assign sa bawat edge. So, halimbawa, in this weighted digraph, kasi directed yung graph, tapos may label yung mga edges, binibigyan lang natin ng associated cost o weight yung bawat edge. So, you can think of it, say, as a transportation network with the weights on each edge to be the cost of traveling along that route. So kung isa tong transportation network, so ibig sabihin from city A papunta kay city B, all right? I can do so because there's a vertex coming from vertex A, or there's an edge coming from vertex A papunta kay vertex B, pero yung cost of traveling along that route is 3 units. Okay? Now, ano bang magandang example? A to B. I'm looking for isang route na dalawang routes na pwede nating i-compare. Meron bang interesting routes na pwedeng i-compare? Halimbawa, going from parang wala pala. Hindi ako matatrap. Hold on. From B to A, isa lang yung pwede kong daanan. From B to C, isa lang din yung pwede kong daanan. So I don't think I can draw up a interesting example here. Probably later. Now, if kung meron kang weighted graph, pwede mo pa rin i-represent ito as an adjacency matrix. Instead of putting 1, whenever 2 vertices are adjacent, you can put as value yung weight nung edge joining the 2 vertices. And still, if 2 vertices are not adjacent, then 0 pa rin yung ilalagay mo sa adjacency matrix. So you can check later if you want that the adjacency matrix of this weighted graph is given by this, right? And again, we have a 3 here because the cost of going from vertex A papunta kay vertex B is 3 units. Okay, and again, there's a lot of things that you can do with the adjacency matrix. This one, the blue numbers here, and connect it with some of the graph parameters. Pero if we will a discussion of that is more of graph theoretic discussion. So hindi ko siya i-discuss na. All right. Okay. Hindi ko na pala, akala ko masisimulan ko pa yung MATLAB code ngayon eh. But sige, let's just finish the rest of the definitions probably for the next 5 minutes, ano? And then we'll start next meeting with a discussion of the MATLAB code, which I will share with you guys. Upload ko tong slides together with the MATLAB code that you can start to explore if you have time before we meet on Wednesday. But that's what we'll do on, when we meet again on Friday. And that's what I'll do on Friday. Yung ko naman sisimulan. Okay. So just some more terminologies here. A path is a route that runs along the edges of the graph. Though medyo, medyo informal yung definition niya. So for instance, this is a path, etong 3, 6, 7, 2, 5. That's an example of a path. That's a path coming from 3 to 5, right? So 3, 5, 3, 6, 3, 6, 7, 2, 5. Isa siyang path, right? But there's another path starting from 3 and ending in 5, right? So it's having a path is not unique. Another such path is 3, 6, 7, 2, 1, 4, 5. That's another path, albeit a longer one, right? So parehas silang path kasi it's a route that will run across the edges of the graph. So again, you can think of, say, the vertices are cities, and then the edges along the edges connecting them would be roads. So a path from 3 to 5 is simply like a road or a route or ano pa bang tawag natin doon? Yeah, trajectory that will lead you from point 3 or from vertex 3 to vertex 5. Of course, if you're talking about economy, you want a shorter path, meaning you will traverse only a fewer number of nodes. But the more interesting problem is paano kapag weighted yung graph, So say this is a network of highways, tapos may cost of traveling along the highways, or halimbawa yung weight would be the length of that particular highway, all right? So pwede mo ma-compute literally ano yung shortest route coming from one city to another, all right? So that's paths for you. Kailangan ko lang to define the distance. Okay. So the path length represents the number of edges that the path contains. So halimbawa yung path 3, 6, 7, 2, 5 natin, kailangan nating bilangin ano yung edges. Ilan yung edges na dinaanan natin para sa path na yon. So this path has length how many? 1, 2, 3, 6, 7, 2, 5. So that's 1, 2, 3, 4. So it's a path of length 4. Okay. Or it's a path of length 4, tama. But 3, 6, 7, 2, 1, 4, 5 has how many edges? 1, 2, 3, 4, 5, 6. So this path, the second path that I drew kanina, has length 6. Right? Mas mahaba yung pangalawang path. Okay. Now, I want to end here. Ano yung notion ng distance? Well, basically, the distance between two vertices is basically the length, the shortest path, or the geodesic path, or the sige na, ito na yung gamitin kong term. Yung shortest path or the geodesic path, this is the path between nodes I and J that has the fewer number of edges. So you can think of it as the most economical path starting from vertex I to vertex J. And we call the shortest path or the length of the shortest path from between two vertices to be the distance between the two vertices, right? Halimbawa, gusto nating computein yung distance between vertex 1 and 4. Yung distance between vertices 1 and 4 ay yung length ng pinakamaiksing path from 1 to 4. right? Of course here, this is one path, right? Yung path 1 from 1 to 4 is a path of length 1, pero there are other paths from 1 to 4. For instance, you have 1, 2, 5, and then 4. But this path is of length 3 kasi dumaan ka sa tatlong edges. Edge 1, edge 2, edge 3. So it took 3 edges to reach 1 to 4 via that route. So that route has length 3. Eh, ang definition natin ng distance, ano yung length ng pinakamaiksing path? So that is, here, the distance between 1 and 4 ay equal kay 1. And then you can try it out for the other vertices here, or for the other pairs of vertices here. Okay. Probably I'll stop here sa distance matrices. Just quickly, yung distance matrix naman, ito yung matrix na ang laman niya ay yung distance between two vertices. So, halimbawa, ang entry kay row V1 at column V2 ay yung distance from V1 to V2. So, we'll consider all of the paths starting from V1, ending in V2, kasi undirected naman to. I think kung directed, ang convention dito sa slides, start ka kay V2, papunta ka naman kay V1, kukolektahin mo lahat ng posibleng paths, tapos pipiliin mo yung pinakamaiksi. Alright? So, yun yung magiging entry dun sa distance matrix. The lengths of the shortest path between the two. So, for instance, V6, column V6, row V4 ay equal kay 4, meaning the shortest path starting from vertex 6 papunta kay vertex 4 ay length 4. Okay, wala ka nang mas maiksing path mula dun sa dalawa. And by default, 0 yung ina-assign natin na distance from a vertex to itself. Lalo na kung undirected naman yung graph. Okay? And then finally, yung graph diameter, siya naman yung pinakamalaking distance among the vertices. All right? So kukunin natin ano yung lahat ng distances sa pagitan ng bawat pair ng mga vertices, tas kukunin natin yung pinakamataas. Yun yung diameter ng isang graph. So if we go back to the previous slide, okay? So tingnan natin yung distance matrix. So this summarizes yung distances between any two vertices in the graph, right? Tingnan natin yung pinakamalaking entry. Yung pinakamalaking entry ay 5. So ang ibig sabihin niya, so 5 dito saka 5 dyan. Symmetric kasi yan kasi undirected yung graph natin. So this means that ang pinakamalayong shortest path from one vertex to another vertex is the one starting from vertex 3 to vertex 4. So that is the longest strip. That's the longest, shortest strip between any pair of two vertices. And that number, the highest distance or the highest element of the distance matrix is what we call the diameter of the graph. Right? So again, yung diameter ng graph, ito yung longest distance. Siya yung pinakamahabang shortest path in a graph. Okay. And we'll stop here. I know that's a lot of terminologies. Pero probably next time we look at a more practical scenario. All right. So what I'll do is to share with you these slides, the video recording, plus yung MATLAB code na paglalaroan natin when we meet again on Friday. Okay. So any questions? Some burning questions that you want to ask right now? Sorry, masyadong marami. Marami akong kailangang habulin, ano. Alright, no questions? Sige na. End share ko muna. How do I end share? Up there. Alright, questions? Okay, so kung wala naman, so thank you guys for joining me today. Pardon the 3-minute overtime. But yeah, let's see each other again on Friday para medyo hands-on naman yung titingnan natin. Kasi ang daming terms ngayon, no, nakakapagod. So next time, I hope you have your MATLAB programs with you. Unfortunately, MATLAB lang yung version ng program na meron ako na i-share ko. Ano? So if you want, you can translate it to other programming languages. But programming languages is just a matter of semantics. Ano? Tomato, tomato lang yan. If you're good programming in one, then it would be easy for you to migrate to the other. So if you want to take advantage of the codes that I'll be sharing with you, so probably you might want to install MATLAB over the next couple of days para sabay-sabay natin paglalaroan yung MATLAB code para sa network analysis. Okay? So with that, so thank you guys and see you again on Friday. Bye.
Bye,
Thank you,
sir.
sir. Bye-bye po.
All right.